Okay, learning objective 2-2, sorry, I did actually label this wrong, is all about the slope of a velocity graph. Remember, our color coding is that velocity is blue and that position is red. You saw a lot of red on the previous learning objective. You're going to see a lot of blue on this learning objective because we're now shifting gears to focus more on velocity and less on position. We are going to do a quick review of how to measure velocity. So if we think about a turtle moving along and we're taking pictures of that turtle every second, we would have these dots here to represent where the turtle is. Velocity is the change in position of the turtle each second. To put that in other words, velocity is the gap between the dots. In these notes, we're going to be making graphs of velocity, and those graphs will really be graphs of the length of the gap between these dots. Okay. So now let's look at this rabbit. And again, this rabbit is going to be moving faster. Objects that are moving faster will have a larger change in their position each second. And if they have a larger change in position, then they're going to have a larger velocity vector, or a bigger arrow, we could say. Okay. So what we're now going to do is we're going to take these velocities and we're going to draw them on a graph. Notice that the y-axis here is velocity measured in meters per second. On the last learning objective, the y-axis was position. The rules are totally different now, and it's really hard to remember to look at that y-axis and actually remember what all the rules are and think carefully about what we're looking at. So in this case, we're looking at this velocity vector as the velocity of the turtle for the first second, or for second 0 right here. And so we're going to graph that velocity right here. Then for second 1, this is the velocity. And we'll see that that velocity is exactly the same. The turtle goes the same distance in the second, or in the first second, as it does in sort of like 0 seconds. And then the turtle will go the same distance in the next second. So you can see that this is constant velocity. When we're drawing a position and time graph, constant velocity looks like this. The object is gaining position every second with a constant slope. But in this case, we're only talking about the velocity itself. And since the velocity remains constant, the y value will remain constant also. Let's look at this rabbit. The rabbit is also moving at constant velocity, but the rabbit is going faster. So we graph the velocity higher up on the y-axis. Here's a comparison. This right here is the rabbit. This is the turtle. Both of them are constant velocity. The only difference is that the rabbit is moving faster and the turtle is moving slower. Okay. Now, what if we change the velocity? What if the object is speeding up? If the object is speeding up, the change in its position, its velocity, will increase each second. This increase in velocity is called acceleration. And the color code for acceleration is going to be green. So let's look at this rabbit. He wants to go even faster. So he has strapped a rocket to his back. And so he's going to start off moving relatively slow, but then he's going to get faster and faster. Show it to be something like this. If we're taking pictures of the rabbit every second, the gap in the first picture is going to be small. The gap for the second picture is going to be bigger because now he's got a higher velocity. And the gap for the next picture is going to be even bigger. And we can see that by looking at the length of these velocity vectors. This one is short, longer, and then even longer. How do we measure the acceleration? Well, this is a little bit more confusing than measuring velocity, because what we're actually measuring is we have to measure the amount of change in the velocity to find the amount of acceleration. So the way we would actually do this conceptually is I would look at this velocity, and I'm going to compare it to the velocity over the next second. The difference in those vectors is the amount of acceleration there is. I would then take this velocity vector and compare it to the next second. And guess what? Once again, the difference in those velocity vectors is the acceleration. Now, this is something that's a little bit interesting to notice. The object gains the same amount of velocity in this second as it does in this second. In other words, this is a constant acceleration. You've got to be really careful about this word constant in this unit, because you got to make sure you know what is constant. Is the object's position constant? No, position is not constant. The object is changing its position. Is the object's velocity constant? Are those vectors all the same? No, the velocity is increasing, but the acceleration is constant, even though those other things are increasing. And that can be a little bit confusing, okay? The equation for acceleration is the change in velocity, delta V, over the change in time. So if you gain 10 meters per second over 2 seconds, that's an acceleration of 5 meters per second per second. On a graph of velocity and time, acceleration ends up being the slope of the line. Just like on a graph of position, velocity was the slope. So look, here we're graphing velocity. We're taking these velocities and we're graphing them onto these points. If we think about it, that means that if we go over 1 second, the amount that we go up is going to be the acceleration. If we look at the next second, we go over 1 second, the amount that we go up is the acceleration. Again, we go over 1 second, and the amount that we go up is the acceleration. So slope is acceleration on a velocity graph. It's not true of every graph, only velocity. All right, so let's do some comparisons. Here are actually, you know what? I just realized this is not exactly what we wanted to talk about. So these are some position graphs. This is what we were talking about in the previous learning objective. So let's just quickly match these position graphs to the different objects. Remember, the slope of a position graph is the velocity. Okay, so we would have the turtle would be here. It has the lowest slope and the least velocity. The rabbit would be here. He has the highest slope and the most velocity. And our frog will be here. He has a negative slope. He's going in the wrong direction. Okay? And you guys are not going to be able to do this step on yours because I kind of wrote it out wrong. But if we were to change this, just as an example, and think about it as velocity, then we would have a line up here, we'd have another line here, and we'd actually have a line down here underneath the x-axis. And if we were to pair those, well, then the turtle is going to be this line right here. He has constant velocity, but it's lower than the rabbit's velocity right here. And the frog would have negative velocity. He'd be over here, something totally different. If we were to look at that on these graphs right here, let's look at this sort of more complicated thing. Well, this is a position graph. So remember, the slope of a position graph is velocity. So if we want to figure out what's going on here, we need to realize that here the object has a slope that's positive and constant. Here the object has zero slope. Then it goes back to that positive constant slope. Then it has zero slope. Then it goes back to the same positive constant slope. Then it has zero slope. And then it has this negative constant slope. All right, so if we just describe that, slope is velocity. That means that we had a positive velocity right here. We had zero velocity right there. Then we went back to positive velocity, zero velocity, positive velocity, zero velocity, negative velocity. Okay, so what is this object doing? Well, it moves and then stops, and then moves and then stops, and then moves and then stops. And then it moves back to where it came from. How would we draw that on a graph of velocity and time? Well, the way we would draw it on a graph of velocity and time is the object moves and then goes to zero velocity, and then moves, goes to zero velocity, moves, goes to zero velocity, and then moves back with a negative velocity for a long time. So notice, really the point here is velocity and time graphs and position and time graphs look totally different. They have totally different rules. And you really need to remember that they are different things and be careful what you're looking at in this unit.